Hello everyone, this is AMMAJI of DUPPADA, and today in this video we are going to see the first method of solving differential equations called as variable separable method. Variable separable method. The name itself, it is telling us something. We are separating the variables. Just here in this method, what are the in the process we do few steps. I tell you. Firstly, the name itself, it is suggesting that we have to separate the variables. So separate the variables. Separate the variables. Then we have to operate integration. Operate with integral operator. We will see, why we need to do, integral operator. Operate with integral operators. Then finally you will obtain a solution. Finally you will obtain a solution. These are the steps actually to do in this variable separable method. But before that, we should be very clear that I already mentioned variables in the beginning video. There are two, like one is dependent variable, the second one is independent variable. So generally, I told you independent variable time we consider in the universe, time as the independent variable we consider. But generally x, comma y, comma z, these consisting of space. They mention generally space, right? Three dimensions. Time is one dimension, another dimension. This time is another dimension. These are the variables we generally represent as independent variable. Even in the in higher classes, maybe in the PhD level, we mention vibration also as one dimension, as a variable, like independent variable. Vibration is also a variable we consider. So generally these three together we call as a triad in higher dimensions of studies. But these are the independent variables. Coming to dependent variable, you can represent with any value, like any term, or any, what do you call, any letter. Dependent variable. So finally, independent variables are time, x comma y comma z, or the vibration you can represent. Dependent variable is one. So this dependent variable, independent variable, you have to separate in the given equation. And second step is you have to operate with integral operators. Third step, after doing some procedure, you will obtain a solution. This is what actually process we follow to solve a differential equation of first order and first degree by using variable separable method. Now straight away we will solve one problem so that we understand. And here one more thing I want to tell you. Sometimes the question may given, like, in mathematics, logic is important. Science they may not consider much. Like, as per science, I told you t is the t time, x comma y comma z are the space, vibration is another dimension. These three together called as triad and generally represent as independent variable. But mathematically, suppose if I say like this, dy by dx. So y is dependent variable, x is independent variable. If I mention dt by dx, maybe t is function of x. Mathematically, logically, in that case, t is dependent variable, x is independent variable. You may think that again. So someone, he said like t as independent variable, how he has given in different direction, like. So in mathematically, anything may be possible. Logically, whatever they have given is right. But scientifically, what I'm telling is generally we consider time, space, vibration as the independent variables. So that is not making a conflict with mathematics. Mathematics simply, it is a logic. Even if I say like d of pig by d of dog, You forget about what is pig, what is dog, is it animals, nothing. Here pig is a variable, dependent variable, which is depending upon dog is another variable that is called independent variable. It is pig is function of dog. We can simply say that. Okay, this is what actually mathematics. So now straight away we will solve a problem. So the problem I take given like this: dy over dx is equal to exponential power 3x minus 2y. This is the differential equation plus x square into e to the power minus 2y. This is the differential equation they have given. By seeing it, I told you firstly you have to observe one thing. What is the degree of equation? 1 differential equation. And what is the order of differential equation? It is the 1. So in this, what are the variables? X comma y it is appearing. So y is on top actually, x is on below. So y is dependent variable, x is independent variable. Now, first step, what I said, you have to identify variables. Anyhow, I have identified. Now, what I want to do, I have to separate the two variables. I have to separate the two variables. So, to do that, what I do is I segregate the term here e power 3x into e to the power minus 2y. A power m plus n is equal to a power m into a power n. That is the simple binomial formula I am applying. Plus x square into e to the power minus 2y. So again, dy over dx is equal to, what I can take common is here, e to the power minus 2y I can take common. So the two terms will remain e power 3x plus x squared. So now you see, little y terms and x terms can be separated by using this. Now what I do is, dy I keep here only, but I will bring e power minus 2y left hand side. So it will become e to the power minus 2y. Dx term I will take this side, e power 3x plus x squared into dx. Now see, now y and dy terms are separated from x and dx terms. So the first task is done. What is first in the process, first step is done. Y and dy terms are separated from x and dx terms. Now I want solution actually out of the given differential equation. I told you solution means the y function of x you have to identify, you have to calculate. It means finally your solution should not have any differential terms. So how to remove differential terms? In order to remove a differential term, you have to operate with integration, because integration differentiation are both are reversible. Like if you operate with integration, differentiation term will go away. If you operate with differential operator, the integral term will go away. So now operate with integration operator, operate both sides, operate both sides with integral operator, this one. So both sides I'm operating 1 over e power minus 2y dy is equal to, I'm operating with integration e power 3x plus x square whole dx. Now I'm taking here. So left hand side 1 over e power minus 2y, I'm taking top, integration of e power 2y dy is equal to integration of e power 3x dx plus integration of x square dx. Actually this much, making equation is not necessary. Directly also you can operate with integration on two terms. To make it understand easily, I am doing this. So integration of e power something only, What about y coefficient is 2 here? So that you have to write by. So e power 2y over 2 is equal to e power 3x over 3 plus integration of x squared. That is the direct formula again, x power n plus 1 over n plus 1. It means x power 2 plus 1, nothing but x power 3 over 3. Plus, I am adding a constant c. See, now you have to understand why I have put this c. I told you even in the beginning, when you are doing with the differential equations, arbitrary constant term will come. If it is single order, so one arbitrary constant you have to add. So e power 2y over 2 is equal to e power 3x plus x cube plus 3c by 3. I think we can write. Now, if you take this 3 by 2 e power 2y is equal to e power 3x plus x cube plus 3c. So 3 into e to the power 2y is equal to 2 into to the power 3x plus 2 into x cube plus 6c. So this is the final equation. This is the final equation. It means final solution. So now you see here in this final equation, only y and x terms remains. No other terms. No other terms. And one more thing is, here arbitrary constants is multiplied by 6 is a real constant. So together you can represent if you want. 6c you can replace with c1 or c2 in the end of the equation or at the end of the solution. 3 into e to the power 2y is equal to 2, you can take common, e power 3x plus x cube plus c1. C1 is an arbitrary constant, or c2, c3, or any value you can put it, because 6 you no need to mention actually here. So that is also, it will become another arbitrary constant. So this is the final solution. It means here if you write y in terms of x out of this equation, that will satisfy the given equation of differential equation. Given differential equation, that is called what is the solution. So today in this variable separable method, the final point is like, whatever the solution you have obtained, that solution should satisfy the given differential equation. That is what actually the first method of various methods that are existing in solving differential equations. So thank you all for watching this video.